first step, okay, free body diagram. Okay, the second step would be a coordinate system. That's the standard steps for doing physics problems. And of course, this picture, sometimes the problem doesn't give you this. You need to draw it yourself, okay? But I didn't put it in there. All right. Now we have a situation. Second step, coordinate system. You are the boss. You can assign any coordinate system on it. Either one works fine. But there always is one, which is the most convenient one. And for this one, you see the three forces, these two are perpendicular to each other. Therefore, the first action would be a coordinate system directly this way. Therefore, three forces, you just need to do one thing on this one and don't touch these two at all. Right? Okay? Therefore, after that, you just draw some dashed line to show the direction of the two coordinates. All right, now, what to do?
Okay.
Decompose forces into components if necessary. Okay, you have three forces, the M, G, and F, they are not necessary. You don't have to do anything. Only this one you need to do something. Therefore, find the component. You just draw one line parallel to X, one line parallel to Y from the tip of this force. Therefore, you will have X component over here, Y component over here. Okay, and therefore look at this picture, compare this with this. This is alpha, which one is alpha here? In this triangle, this one is alpha or this one? The top one, okay? Therefore, you label alpha over here. Therefore, in this triangle, you know the hypotenuse is T. You know the angle is alpha. How to calculate this? Opposite side of this angle, right? Therefore, opposite is always sine. Therefore, this force, you just label it as T times sine alpha. And this one, the Y component, which is the adjacent side of this angle. Therefore, it's always cosine. All right. When you finish the decomposing, you go to a Newton's second law. Well, Newton's second law, everybody knows sigma F equals ma, right? Okay. Just use it. All right, in X direction, you have two forces. One is this F, one is T sine alpha. This symbol, sigma here, means sum. You have to add them up. Therefore, you have F plus T times sine alpha. It must be equal to ma. But be careful. F is positive according to your assignment. And this one goes backward. It is negative, right? So when you do the addition, don't forget, put down negative sign with the parentheses. It's negative. And this is X direction, therefore you label the acceleration as AX. Okay, that's X direction, the Y direction. You still have two forces. One is this component, one is gravity. Therefore, according to Newton's second law, you still need to add them up. T cosine alpha up, which is positive, plus mg. It must be equal to ma according to this formula. And mg is positive or negative?
Negative.
Going down, therefore, it must be negative. Then you have a second equation. Of course, this is a1. Okay? And as a beginner, I suggest you do this. Okay? Put down negative sign with a parenthesis. If you are a senior student, you don't have to. You just directly F minus this minus mg, right? Okay? And now, you need to consider one thing. In this picture, is this sphere moving?
No.
No? Which means this is in an equilibrium state, right? Therefore, what's the value for this acceleration?
0.
0. What's the value for this one?
0.
0. Therefore, the two equations become so easy. They are all zeros. So what do you want from them? You want the tension. And anything else?
Yeah. Q. Oh, are we on number 7? Yeah, they want Q first and then.
Oh, how large the charge is, right? Okay. The Q is here, Q is here also. All right. Let's do it. Therefore, solving the problem becomes a mathematical process. Okay. All right. And right now, we need a little help from the thing we just learned the last time, because in these two equations, this is fine, this is fine, this is also fine, but this is not. You just label a F. What is F?
K, Q.
Okay, therefore, Coulomb's law. Coulomb's law will give you F equals 1. And it equals K times Q squared over R squared. What's R?
Distance.
Is R given?
Yeah.
How many?
It's like
50
cents.
centimeters. Therefore, 50 centimeters, 0.5, right? Okay.
You always have to go to meters.
Yeah, but wouldn't we divide that by 2?
No, because that's the middle line. That's the distance they are from each other.
Oh, yeah, that. But are we only using half of the diagram though? For our
This
mathematics?
distance is 50, right?
Yeah.
Therefore, it's 0.5 meters.
But
That's
didn't we only
good.
do all that stuff only with half of the diagram?
Half this?
Yeah, for all of our other math.
That's only to find that,
That's always find the equation.
because that's the angle from MG.
This line only tell you this angle, nothing else. Doesn't do anything. Just tell you this angle,
Yeah, I
nothing
get that. I
else.
just didn't. I was thinking that we were just doing half the diagram because that's what you said at first.
Oh, it doesn't matter. It's half diagram or the other half, whatever. It doesn't matter. We just follow the equations. Equations will answer all your questions. All right. So therefore, from here to solve it, there are a lot of tricks to solve the equations like that. You just go the easiest way. Okay. You see, if I were you, I would change this equation to a new form. It becomes t times sine alpha equals f. And f is what? Right?
Yeah.
Well, I just basically move this term to other side and become positive. Therefore, I just flip it, you see? That's it. And the second one, I will write it down differently as this. I just make it easier. Therefore, what was next? You have two variables. One is the tension, one is Q, right? You want both of them. To solve the equations, you have to remove one of them in order to get the other one, right? how to easily get rid of one step?
Do the opposite.
Can you remove t? How?
Just divide by t.
Okay, that's so easy. See, t times sine alpha divided by t times cosine alpha. What happened here? All they cancel. Of course, okay, if you take this ratio, what's the other side? This side divided by this side, then it will equal to what? This side over this side, right? Oh, that's easy. Therefore, k times q squared 0.5 squared divided by mg. Therefore, the two t's cancel. No t. You only have a q here, which is what you want. You just solve this equation for q. Okay, let me write it down. Let's say solve the equation set. You only have a set of equations, not one. Usually more than one. Okay, so the following is mathematics. Sine divided by cosine is called what? Tangent. Therefore, this equation becomes mg times tangent alpha equals kq squared over 0.5 squared, right?
Very good, Doctor.
Any questions on that? How to change it to this form? Because this guy is tangent, right? You just multiply mg both sides, you got this one. And now you need to do another thing. Multiply 0.5 squared both sides. You removed all the denominators. That become a piece of cake. If you want q, therefore q squared equals what? Let me know.
0.5 squared mg tangent.
All the things on the left
Okay.
in the numerator, right? Divided by k, that's it. And you don't want q squared, you want q, right? Therefore q equals what? Oh, square root of the whole thing. Then just double check here to make sure that you know everything in this solution. And 0.5 squared, no problem. mg, yeah, no problem. And alpha is given 30 degrees, and k is a constant. Everything, we know everything. Then job is done. Oh, you said no, not yet. We still want the tension, right? Okay, how to find the tension? And pick up this one, the tension equals what? mg over cosine alpha, right? Job is done. Now you know everything here. See, Newton's laws, they work everywhere in physics. No matter what you are studying, they are always helping you. I hope you can memorize those standard steps. And when you have a problem which is thought complicated, if you follow this, you can always solve it easily. But the difference between